In this video, I'm going to show you the Excel skills for section 2.4 in your book. This section talks about variance and standard deviation. And in the notes and in your book, it shows you the long way to do the formulas by hand. I think it's very good to look at the derivation of these formulas and kind of understand where they come from and what they mean, but please know that you are not expected to do any of this by hand. I would expect you to use Excel to do the calculations because it saves you significant time and effort, and in the real world nobody's going to ask you to do these by hand. They're going to expect you to do it with some type of technology. So if you want to do it by hand, that's fine, but please know that it's expected and it's much easier if you just use these Excel functions that I'm about to show you. So population variance is a way to describe how spread out the data is within a population. And to calculate population variance, we're going to go up to Function Wizard. And as I'm getting into this is the same data that we've been using for pretty much all of Chapter 2, if you want to follow along. So Function Wizard, and then change that drop down to Statistical, and then go down to the V's for Variance. If you notice, we have a couple choices, but if you click on var.p, it tells you this calculates the variance based on the entire population, and that's what we want. So we're going to pick var.p, and then highlight all your data, and click OK. And Excel does all the math for you, and it tells you your population variance. Similarly, to find sample variance, we'll go up to Function Wizard, scroll down to the V's, and this time we're going to pick var.s to estimate the variance based on a sample. So click OK, highlight your data, and click OK again, and that gets you your sample variance. Now, variance isn't really used a whole lot in the real world because these numbers are huge. And the reason they're so big is in the formula to calculate variance, you look at the deviations when you do the x value minus the mean, and then you square them to make them all positive so that when you add them up, they don't cancel each other out. Well, because we squared them, when you square a number, that makes it really big. And so all these variance values are those numbers squared and added together and divided by the total number, which is really big numbers. In the real world, we almost always use standard deviation, but we have to have variance as a stepping stone to get to standard deviation, which is kind of the point. And in the formula for standard deviation, it is the square root of variance. So what happens when you take that square root is, in essence, it cancels out all the squaring, so it brings the numbers back down to scale. So to find population standard deviation, we'll go up to Function Wizard and go down to the S's for standard deviation. And we want stdev.p to calculate the standard deviation based on a population. And again, we just highlight everything and click OK. It's pretty easy. And you see the standard deviation, if this is the population, is 100. So it's telling us there's about a 100 unit spread within the data, which makes much more sense than like a 10,000 unit spread. And then to do the sample standard deviation, again, we go up to Function Wizard, go down to the S's, and this time we want stdev.s to get the standard deviation based on a sample. Highlight everything and click OK. So in this video, we're looking at the data pretending it's a population and pretending it's a sample. The problem, it'll tell you whether or not it's a population or a sample, so you only have to do one, but I wanted to show you all of these functions. And one thing that's important to notice is that the sample values are a little bit bigger than the populations in both cases. And the reason this is in the formula for the variance and standard deviation for a sample, you're dividing by a denominator of n minus 1. That's making the denominator of the fraction a little bit smaller, which makes the overall fraction a little bit bigger. Think about 1/2 and 1/3. The 2 in the bottom is a smaller number, but 1/2 is a bigger value than 1/3. And what this is doing is it's giving us just a little bit of an overestimate. We realize that samples are very rarely an exact match to the population, and so we would rather slightly overestimate the variance and the standard deviation than underestimate it. So because samples are never a perfect fit, that's why the standard deviation and variance for a sample is just a little bit bigger, because again, we're giving ourselves just a little bit of overestimation.